You are constantly being bombarded by gamma rays, but sadly they're not going to turn you into the Hulk. Let me explain. Gamma rays are one of three types of ionizing or nuclear radiation, these being alpha, beta and gamma. Alpha, beta and gamma are called ionizing radiation because when they come into contact with atoms they have a habit of knocking electrons off from around the outside of them. This causes the neutrally charged atom to become a positively charged ion. The more ionizing we say a radiation is, the more likely it is to form an ion when it hits an atom. Gamma rays are the least ionizing of these three types of radiation, coming somewhere here on the electromagnetic spectrum, and all they are is an electromagnetic wave. This means they pass through most things without interacting with them, which makes them the least ionizing of these radiations, but they could go on for miles, and you need tons of lead and concrete to actually stop these gamma rays. Gamma rays are also normally formed as a side product of other types of radiation, such as alpha or beta, but also in parts of fission and fusion reactions, as well as when stars die in supernova. We live next to a giant nuclear fusion reactor we call the Sun. This means that we are constantly being bombarded by gamma rays, and these gamma rays are passing through us most of the time. Alpha and beta radiation pose more of a threat to humans, with alpha being the most dangerous because it is the most ionizing. Alpha radiation is just the emission of a helium ion from the nucleus of an atom. This means the atom loses 2 protons and 2 neutrons, and as we've already discussed, this means it changes what type of atom it is. Beta radiation actually comes in 2 types. The most common case, known as beta negative, is where a neutron decays into a proton and releases an electron. This also releases an anti-electron neutrino. The less common one, beta positive, is where a proton becomes a neutron and releases a positron or anti-electron and an electron neutrino. Both alpha and beta radiation can be stopped by other materials. Alpha can be stopped by paper or foil. Beta radiation needs a little bit more insulation but will be stopped by most other materials. Also, compared to gamma radiation, both of these are relatively short range. Gamma radiation has a theoretical range of infinity, whereas alpha and beta have a range of only a few meters, or in alpha's case even a few centimeters. This has been day 3 of my nuclear physics week, so please like and follow so that you don't miss any. And let me know in the comments if you've got any questions or if you've got any suggestions for future topics that you might want me to cover. And until next time, I have been Dr. Alex Foden, the Science Wrangler, and I shall see you one of these days.